Hello everyone. Today we are building an awesome height measurement tool that will measure the heights of object or people and display the values in the serial monitor. Let's get started. For this project, you will need an Arduino Uno, an HC SR04 ultrasonic sensor, some jumper wires, one USB cable to upload the code and power the Arduino as well. Now let's connect the ultrasonic sensor to the Arduino. Connect VCC pin of the sensor to 5V of Arduino. Connects its GND pin to the GND pin of the Arduino. Connects its trig pin to D9. Connects its echo pin to D10. Make sure to double check your connections with the circuit diagram. In the distance measurement tool, we calculate how far an object is from the sensor. In the height measurement tool, we determine the height of an object below the sensor. The key difference in the code are, instead of displaying the distance from the sensor, we subtract the measured distance from a fixed reference height. As for example, if the sensor is mounted at 30 cm, we subtract the measured distance from 30 cm. We introduce a new constant, sensor_height, to define the fixed height of the sensor. The initial value displayed is the height of the object or person below the sensor rather than the direct distance. Now download the code file given in the description below. Open the code file if you have already downloaded the Arduino IDE, otherwise download the Arduino IDE first. At the beginning of the code, we define three constants. This is the pin on the Arduino that sends us an ultrasonic sensor signal. This receives the reflected signal to calculate distance. The height at which the sensor is placed above the ground, in this case 30 cm. You may vary the height according to your requirement or the height over which you can mount the ultrasonic sensor. These constants ensure that we can easily modify the code later if needed. Next, we have the setup function, which runs once when the Arduino is powered on. Serial.begin 9600 initialize the serial monitor to display results. Pin mode function trig_pin, output sets the trigger pin as an output so it can send signals. Pin mode echo pin, input sets the echo pin as an input to receive reflected signals. Now we move to the loop function, which runs repeatedly. Digital write trig pin, low ensures the trigger pin is low before sending a new pulse. Delay microsecond 2 provide a short delay for signal stability. Digital write trig pin, high sends a 10 microsecond pulse, triggering the sensor to emit an ultrasonic wave. Digital write trig pin, low stops the pulse. Pulse in echo pin, high measures the time in microseconds between sending the signal and receiving the reflection. This duration is essential for calculating the distance of the object from the sensor. You may ask, why multiply by 0.0343? Actually, the speed of sound is 343 meters per second or 0.0343 cm per microsecond. Multiplying the duration by 0.0343 converts it into distance in centimeters. And also, y divided by 2? The sound wave travels to the object and back, so we divide by 2 to get the actual distance from the sensor to the object. Since the sensor is mounted at a fixed height, we subtract the measured distance from the sensor height to get the actual height of the object below it. Serial.print height prints the level. Serial print height displays the calculated height. Serial print in centimeter adds centimeter and moves to a new line. This ensures the height is displayed clearly on the serial monitor. This half-second delay prevents the reading from updating too frequently, making it easier to read values. And that's it. Now upload your code to the Arduino, connect the Arduino Uno to your computer using the USB cable, then select port and board in the same menu and select Arduino Uno. Now upload the code by clicking the upload button, and with everything connected and code uploaded, open the serial monitor, set baud rate to 9600. Make sure to mount the sensor to some height as you mentioned in the code. In this code, the height was set as 30 cm. Now stand an object below the sensor and check the displayed height. The height should change accurately. By making small changes in the code, you can modify the output format. For example, to display height in millimeters, make these changes in the code. Multiply the height in centimeter by 10. Let us upload this code in Arduino and check the output. And if you want to display height in inches, make these changes in the code. Divide the height in centimeter by 2.54. Now again connect the Arduino Uno to your computer using the USB cable, upload the code and see the result. And that's it. Your height measurement tool is ready to use. If you found this tutorial helpful, don't forget to like, subscribe and comment for more Arduino tutorials. Thanks for watching and happy coding.